So in this video, we're going to be looking at probability sample space diagrams. And this is easiest shown by example. So imagine a game in which we get scores by spinning spinners. There are two spinners and we add the scores together to get a total, and then we can move accordingly. How many possible scores can we get? So a way of doing this is by drawing a sample space diagram. And to do that, we look at the two spinners and we see the numbers in the two spinners. So in the first spinner, we can get 1, 1, 2, 2, 3 and 4. And in the second spinners, we can get the numbers 1, 1, 2 and 3. So if we're filling a table accordingly, so vertically for spinner 1, horizontally for spinner 2, and then by adding the scores together, we can complete the table to get the possible scores that we can get. And this is known as our probability sample space. So these are all the possible combinations of results that can be got from these two spinners. And as you can see, there are a number of different scores that can occur more than once in different ways. And we'll use this, we'll often be given loads of questions to answer it. So here we are, I've got a number of questions. So first of all, how many possible outcomes are there? Well, if you count up all the green ones, you see there's 24 of them. What's the probability of the total score being 2? Well, what we could do is we could circle the scores that are 2 and count out how many circles we got. So we've got 1, 2, 3, 4. So the probability is 4 out of 24 possibles. And that can simplify to 1 out of 6. All right, getting to 5, well, exactly the same thing. We can circle the 5s. So counting them up, and we're going to have 1, 2, 3, 4, 5 of them, and it gives us 5 out of 24. Okay, and we can keep going with this. What is the most likely total? Well, the most likely total are the scores that occur the most. And if you look here, both 3 and 4 occur the same number of times. So they're the most likely scores that we're going to get. Then we can answer other questions. What's the probability of getting a score of more than 4? Now I'm lucky, I can delete all this and start again. So more than 4, if it's more than 4, it's any number which is above 4, so 5, 6 and 7. And we count it, we find there's 8 of them out of the 24 that there were in total, which can simplify to 1/3. And similarly, this time 3 or less. Now that's going to include the 3. So we count anything that's a 3 and below. So we circle all of those. We count them up. We find there's 10 of them out of the 24. So that simplifies to 5 over 12. And notice we're given answers as fractions. Okay, now clearing those that data again, we're now going to see between 5 and 7 inclusive. Now 5 and 7 inclusive, that means it includes 5 and 7. So we circle everything between 5 and 7, including 5 and including 7. We count them up, we see how many we got, 8 out of 24, which is again probability of 1/3. This time between 1 and 4 exclusive. Now exclusive means we can't include 1 and 4. So everything that's between 1 and 4 but not including 1 and 4. So basically 2s and 3s. So again, circle what we want, count them up, 10 out of 24, which simplifies to 5/12. And then the last part, what is the probability that the score is odd? Well, again, because I can clear the table, we can make it easy to see. So I clear the table and I'm going to circle every score that's odd on there. So they're going to be 3s, 5s and 7s. Okay, I count them up and I find there's 12 of them out of the 24, which is the same as a half. And so we were able to simplify. And that's how we can use our probability sample space diagram.